Welcome to the second half of Gridworld Part 4. In the last half, we took a look at Critter in detail. It's a new creature that extended actor and added all sorts of different behavior using the grid and using locations. He moved around, he ate flowers. In this half, we're going to take a look at Chameleon Critter and Crab Critter, two new critters, and see how they work and what they do and how they're different. The first thing you want to do is simply run Chameleon Runner. That creates a bunch of colored rocks and a couple of chameleons. And let's just see what happens. Here we go. My chameleons start out. They're little lizards. They're very cute and they're blue. And you see that one guy right here? He moved and he changed color. And you can see as they move next to something, when they move away, they pick up that color. They're still moving pretty randomly, but every time they come next to something, they pick up that color. So this is some new behavior. So let's take a look at Chameleon Critter, see how he does that. Chameleon Critter, in this case, he extends Critter. He acts a lot like a critter. He's going to move randomly. Maybe he eats, maybe not. We'll see. But a lot of Critter is going to be reusable. So we don't want to extend actor. We certainly don't want to extend bug. But Critter makes sense. We'll override what we need to override and not override what we don't. So let's take a look at what he's got. There's really not much to him. He doesn't have a constructor. He's going to inherit down and work just the same as Critter works, a default constructor. Nothing exciting. What he does change, though, is process actors and make move. Everything else is going to work just like a normal critter. So when you're writing classes, when you're extending critters or bugs, you want to think about that. What should I override? What do I not need to override? These are important decisions you can have, especially on the free response question, which is always one about Gridworld. So in this case, he's going to work exactly the same. He's got the same act. We know it's going to work the same way. He's going to get the actors around him. He's going to call process, but in this case, process is overridden. What he's going to do, and I can see in the comments here, he's going to randomly pick one of his neighbors. We're not interested in eating those flowers anymore, and we're going to change color to match them. If there's no neighbors, we're not going to do anything. So let's see how that happens. Get actors works the same. That's in act. I don't need to worry about that. I have that inherited from Critter. I treat it as if it's my own because it's public. Process actors, though, same header, right? Because we're going to override him. I want everything else to work right. And I'm going to say, hey, is there anything in my list? If there's not, I should stop. There was nobody around me. Shouldn't do anything. But if there was something in my list, I'm going to get a random int, remember math.random, times the strength of my list, truncate it to an int, go to that list and get that random guy, drop him in an actor variable. Remember polymorphism? That allows this all to work. Who cares? Rock, flower, critter, doesn't matter. They'll all go in actor. And what I'm going to do is I'm going to call my setColor method. This is going to inherit all the way down from actor. And I'm going to say, hey other guy, what's your color? I'll get that color, and I'll set my color to it. So he's not eating anybody, he's just changing colors. Very different behavior, and all we had to do is change one method just a little bit. The other thing that's changed is he's moving randomly, which is fine. But you may have seen when he moved randomly, he also turned. That is not something our normal critter did. How did he make that happen? Well, all we have to do is make a minor change to make move. Make move is when we finally actually move. So we're going to get the same locations. We're going to select the same location. We work in the same way, but when we make the move, I'm going to add a little bit of extra behavior. I'm going to set my direction to my location, and I'm going to ask my location, hey, what way is it to get towards the place I think I want to go? Remember, select location, pick that. That's going to be a number, 0, 90, 180, who knows. I will set my direction first, and then otherwise, I'm moving just like a normal critter. No reason to rewrite all that code. Super.makeMove, pass the location, I'll do the movement. So I added what's unique to me, just like you might with a toString, and then I use my own super method. Works perfectly. Very simple changes to make a fairly different creature. This is a common thing that you might be doing. The last class we want to take a look at is Crab Critter. Crab Critter adds even more complicated logic and methods. First thing again we want to do, run what we've been given and just see how it works. I'm going to take my Crab Critter here, run it, walk through it. Here we go. Great. I start out with, I can see here if I open it up, bunch of rocks, bunch of flowers, some bugs, pretty cool, and some crab critters, very exciting. And here's my crabs. I got a little crab image. Awesome. And they're all red. Let's step through it. Let's see what happens. Well, these guys, the first thing I may have noticed, hopefully, is that these guys are only moving sideways. They don't get to move forwards and backwards. That's like a real crab, sort of. And the other thing you may notice, and you saw right there, when this guy was here, what happened to that flower? In fact, he ate that flower. So this guy is moving sideways, and he's eating stuff. But he can only eat stuff his claws can get to, which is the stuff in front of him. Take a look at the code, see how that's actually working. Again, we're not extending actor, we're not extending bug. A lot of critter is going to be fine. The act method, the fact that I get actors, that I process them, all of that's going to be good. But I'm just going to change how some of those things work. So I'm going to extend critter. I'm going to add a constructor. In this case, I'm just adding a constructor because I want these crabs to be very distinct. I'll make them all red. Very easy to see them. I can take a look at my other methods. I've got to get actors. That's overridden, right? We're going to change that a little bit. Because remember, we're not getting everybody around me. I've got to get the guys in front of me. And that's a little more complicated. Get move locations. Remember, this is the places I can move to. Well, this guy, he can only go left and he can only go right. We've got to change how those locations are selected. Make move works a little differently because if he gets stuck, and only if he gets stuck, does he start turning. Well, that make move, just like a chameleon critter, it's a good place to handle that. And the last thing we can see here is a brand new method. This is a very handy method. The idea here is that I need to get locations in particular directions. Maybe the three in front of me, maybe the one to the left and the one to the right. Who knows? But the idea here is having a helper method means I don't have to rewrite this code a bunch of times. I give it an array of ints, because remember every direction is an int, and this will walk through getting those locations for me. It's a little complicated, but once you see it and walk through it, it's actually very handy. So let's start. Again, we're going to have critter's act method, and we're going to step through it step by step, just like a critter would. Here's my critter, here's my act. I haven't overridden it. This is the version it's going to get run. Hey grid, do I have a grid? If I don't, we better stop. Hey, let's get people. Let's get the actors. In this case, I only want the actors in front of me, so we have to change how get actors works. Let's take a look at that. Same method header, remember, because we're overriding it. What I'm going to do in this case is I'm going to build an empty array list. I've got to have a place to drop these guys in. I'm going to build using an initializer list. You should be familiar with this, right? The locations that I want. These are really just three ints. Remember, you can say location dot a direction, and it'll be whatever the number is. Right? Location dot ahead, it's going to be 0, half left, half right. These are going to be just ints. I'm going to take get locations and directions, and I'm going to call it. I need to call this first. This gives back an array list of locations, remember? It's that helper method. I've got to run this first, and then in its place is going to go that great array list that I can loop through, I can see who's there, and I can put them in my list of people to do something with. But first we've got to go and get those locations. I'm going to drop in here. I'm going to take in my array with those three directions. I'm going to create an empty array list of locations because I've got to build locations and drop them in there. I'm going to grab onto the grid and I'm going to grab onto my location. This is handy so I don't have to keep typing get grid and keep typing get location. I can just say gr or loc. Very simple. Got a for each loop. I'm going to loop through. It's only 3 ints, but I want to loop through it. I might make a different kind of crab that has all sorts of extra ints. Who knows? And what I'm going to do here is I'm going to go to my location and I'm going to say, hey, get the adjacent location based on my current direction plus the direction I've gotten out of this list. So in the case of a head, it's going to be my direction plus 0. In the case of a half right, it's going to be my direction plus 45. Half left is going to be my direction minus 45. This is going to get those 3 locations in front of me one by one. I will put that location in a variable. I'll check with the grid. You've always got to check. Hey grid, is that location a valid spot? If it is, we'll drop it in our list of neighbors. Loop through those 3 ints, and I'll give it back. We'll use this method again when we get our locations to move. So it's very handy having it in a separate method. Those 3, maybe not always 3, locations come back. We'll loop through each of them. I'll say, hey grid, get me whatever is at that location. So this will get me each of the actors, one by one, that's in front, or head left, or head right. So long as they are not null. Remember, getGrid.get, if there's nothing there, it gives back null. If they're not null, we'll drop that guy in my list, we'll give him back. Awesome, I've got all those guys in front that my claws can get to. You'll notice the next thing we want to walk to, if I take a look at Critter here, is process actors. But process actors we don't have here in Crab Critter. In fact, process actors, we're going to do the same way a critter does. If it's not a rock, if it's not a critter, we're going to eat it. I don't have to override it. It's no problem. Really all I changed was which boxes, which locations I looked at. No problem. Then we've got to think about, how does this crab move? Well, he moves side to side. That's a little more complicated. Get move locations is going to be the next thing I call, and I've overridden that. Because remember, he walks differently, left or right. Same idea, make an array list of locations, make an array of the directions I want to go, in this case just left and just right. It's 2 ints, but it's very flexible. Go to that helper method and get the locations based on those ints. Well, great. It's going to get the location 90 to the right and 90 to the left of me. We've already looked at that. Very handy method. Loop through those locations, go to the grid, and see if there's anything there. If there's anything there, I don't want to try to move there. So this is going to say, if it's null, if it's empty, put them in the list. Maybe it's 1 spot, maybe it's 2 spots. Who knows? We give that list back. Again, I hop back to where I was. Drop that list in move locs. Select move location. We don't have that in Crab Critter either. No problem. Critter already handles that and randomly picks one of those locations. That's fine with me. Sometimes I'll move left, sometimes I'll move right. No need to change that. It's a random selection. Finally, we've got make move. Make move we have overridden as well, because if I can't move, I turn left or right. Not quite like a critter. So what I'm going to say is, hey, if the location I randomly selected that I think I want to go to is the same as my location, that means I couldn't move, right? Because I was stuck. It's only the same as your location if you're stuck. I'm going to generate a random number. And what I'm going to do is, if that random number is less than 50, so 50%, I will set the angle I want to go to location left, minus 90, right? Otherwise, plus 90. Change my direction to my current direction, and this will randomly be half and half, either minus 90 or plus 90. That'll move me to the left or the right. If I could move, because remember, we only turn if we're stuck. If I could move, we'll move just like a normal critter, no problem. Super dot make move. No issues there. So a fair bit of things not only changed, overridden, but also we had a helper method added. This is about as complicated as a critter is going to get. What we'll look at when we do labs is we'll create new critters and new crab critters, and we'll add different kinds of behavior. Some of our behavior will be even more exciting than moving left and right, grabbing the guys in front of me.